This movie describes how to use the ID the suspects identify functions activity. This is one of the geometric functions activities in which students create, manipulate, and experience function concepts by treating geometric transformations as functions with points as their variables. In this particular activity, students explore relationships between variables, distinguish the independent from the dependent variables, and use examples and non-examples to create their own definition of what a function is. You can find out more about geometric functions at this URL. On page 1, students experiment by dragging point variables to determine which variables are independent and which variables depend upon others. For instance, dragging variable A, they see that it's an independent variable and that it affects dependent variable Y. They try to drag variable B and it won't go anywhere. It's actually a dependent variable that depends on some other independent variable. Dragging C reveals that it's an independent variable that determines the location of variable D. Dragging E, well, you can't drag E, so it must be a dependent variable. Let's try W. W is the independent variable for dependent variable E, but it seems to have two dependent variables and not one. Variable V is independent, but it has no dependent variable to go with it. And finally, variable Z solves the question of what was the independent variable that controls dependent variable B. On the next few pages of the sketch, students experiment by manipulating examples and non-examples of functions. On page 2, they find this example and non-example. X to x prime is a function. It exhibits some interesting behavior. Y to y prime is not. In fact, it's called a relation, but not a function, because its dependent variable has two possible locations and not one. On the following pages, students encounter and think about more interesting cases that they need to think about in formulating their definition. For instance, on page 5, students encounter this case. A to A prime is not a function, but B to B prime is the interesting case here because B prime doesn't actually move even though the arrow suggests that they're linked. So students must consider the interesting case of what is a constant function and how this will fit into their definition. On page 8, students find some other interesting behavior. Discrete behavior. R to R prime is obviously not a function. S to S prime is a function, but these discrete functions behave rather differently from the continuous functions that they've looked at before page 8. On page 9, students find a challenge because the arrows no longer appear linking the independent and dependent variables. This emphasizes the fact that these functions actually are based on the behavior of the two variables and not on any visual connection between them. There's another problem on page 9, which is that it's not so clear which one is a function and which is not until they vary z by enough to see that for some values of the independent variable, there's only one dependent variable location, and for others, there are two. On page 10, students again find the difficult case of a constant function, but without the arrows to prompt them to it. So they really do have to think about this particular case. On page 11, they again encounter discontinuous behavior, but not discrete. So m to m prime is clearly not a function. N to n prime is a function, but it's quite discontinuous. It has these jumps to it that are pretty interesting. On pages 12 and 13, students have an opportunity to create their own examples and non-examples of functions for their classmates to try out. As they explore all these examples and non-examples of functions, students solidify their sense of independent and dependent variables as they formulate and discuss their own definitions of function. The physical activity of varying the independent variable, the visual observations of the effects on one or more dependent variables, and the interesting and problematic cases they've investigated can all help students to arrive at a clear understanding and a robust definition of the function concept.